In this video, you will learn the difference between direct and inverse proportions and how to solve each type of proportion. And remember, a proportion is two ratios that are equal to each other. The two different kinds of proportions are direct and inverse proportions. And a direct proportion is when an increase in one quantity causes an increase in another quantity, or oppositely, they both decrease. And this would be what it looks like if A goes up, B goes up, or if A goes down, B goes down. And these type of proportions can be solved with your basic cross multiplying. Here are some examples of direct proportions. The more surface area you have to paint, the more paint you need. The shorter the wire, the less resistance. And the more time you work, the bigger your paycheck. An inverse proportion is sometimes called an indirect proportion. And an inverse proportion is when an increase in one quantity causes a decrease in the other, or vice versa. So for example, for an inverse, if A goes up, B goes down, or if A goes down, B goes up. And here are some examples of those. The more you eat, the less hungry you feel. Or the faster you travel, the less time for the trip. Or the less volume, the greater the pressure. So when you're solving inverse proportion problems, you need to invert the second ratio, basically. So for a direct proportion, you have a ratio that says A over B equals C over D, and A and C are related. So for these types of proportions, A and C are related to each other. And these are the two that are related. For an inverse proportion, A and C are related, but if A is going up, C is going down, and vice versa. So here's our example. If you're going 50 miles an hour and it takes you 2 hours to make the trip, how long will it take you if you're going 60 miles per hour? So is this a direct or an indirect proportion? It's an indirect proportion, and let's see how we're going to solve this. All right, so we're going to set up our proportion 50 miles an hour over 60 miles an hour. So these are the speeds, and over here are our times. So 50 miles an hour, it's inversely related to the time. 2 hours is on the bottom. 60 miles an hour is our other speed, and the time it takes over here is going to be on the top. And since they're inverses, they should be on opposite sides. So now that we've set up our proportion, we can cross multiply. And to solve it, we're going to do 50 times 2 hours, just a little reminder on how to cross multiply, equals 60 times h. And we get 100 equals h times 60. And I want you to note that as we're doing this, these units for miles per hour cross out. So what you're going to have left over is hours. That's what your final answer is going to be. And then you end up 100 divided by 60 is going to give you your time, and you end up with 1.67 hours, or it's like an 1 2/3 hours. Okay, let's look at another example. This one has to do with gears and pulleys, and they're an example of inverse proportions. Now, gear A has 16 teeth and is turned by a shaft at 120 RPM, and gear B has 10 teeth. What will be the speed of gear B? And here's a helpful hint. Set up the inverse proportions first in words. So if you're setting these up in words, teeth A over teeth B, so we're going to set up one of the ratios. So the ratio is going to be, if you flip it over, speed B over speed A. So notice that the A will be on top on one and on the bottom on the other. If we do that, then we're getting the inverse part correctly. Okay, so let's look at, we got 16 over 10 and 120 on the bottom. 16 and 120 go together, so those are our A's. 10 and B are our B's. Okay, so we cross multiply 16 times 120 equals 10 times B, and we solve it, and we end up getting that B is 192 RPM. Here's another example. A headlight is mounted at a height of 3.5 feet, and the beam drops 1 inch per 35 feet. How far ahead will the beam illuminate? Okay, let's remember our helpful hint. that we have to try to set it up, but first we have to decide, is it going to be direct or indirect? For this one, it's going to be direct. So when we go ahead and set this up, the proportion, in words, we're going to set it up as a direct proportion. In words, we're going to have inches probably on the top, because we already have one right here. We already have the proportion, or one ratio set up that's going to guide our proportions. Inches on the top and feet on the bottom. So inches in height on the top, feet on the bottom for distance. So there's the first one. That's the one that they gave us. That's the drop that's happening. So on the top, we're going to have to figure out, they gave us 3.5 feet for the height that the headlight's mounted, but we need to convert that. Remember your conversions, making your bridges. You end up with feet on the bottom and 12 inches on the top. That goes away, you end up with 42 inches here. And so if we do some cross multiplying, we get our final answer of the distance is 1,470 feet. All right, here's our last example. When a tire is inflated, the air pressure is inversely proportional to the volume of air. If the pressure of a certain tire is 24 psi when the volume is 110 cubic inches, what is the pressure when the volume is 160 cubic inches? And again, a helpful hint, when the proportion is set up in words first, it's a lot easier to do. Okay, so let's set this up in words. Volume A over volume B, pressure B over pressure A, because we saw right here that it's inversely proportional. Inverse means if A is on the top over here, then it has to be on the bottom over here. Okay, so we're setting it up 110 cubic inches over 160 cubic inches. Okay, 110 goes with 24. Notice that there's our A's. Also, notice when we're doing this that the cubic inches cancel each other out. So you're going to end up with PSI, which is what we want as our answer. Do some cross multiplying, and you're going to end up with B of 16.5 PSI. So I hope that this video has helped you learn the difference between proportions and which ones are direct proportions and which ones are inverse proportions. And hopefully when you go to solve these problems, you'll be able to think about these two examples right here and be successful in everything you're doing.